All right, so this is the key to the problems from the previous test. So let's look at number one. And number one, you want to solve the following linear equation. So I want you to notice, though, that you do have some grouping symbols. So you have parentheses here, here, and here. And the fact that this variable expression, 3x minus 2, x plus 3, and x minus 2, are all being raised to that first power, each one, then we could use the distributive property to multiply both of those terms in the first variable expression by 4. So we're going to distribute the 4, meaning that we're going to multiply both of those terms by 4, only because the that variable expression is being raised to the first power. Same thing here, except even though it says subtract 7, remember subtraction I can always change to an addition problem by adding the opposite. So this I can think of as adding a negative 7. So I'm going to distribute the negative 7 here. And then over here you need to be careful because you have to follow the order of operations. So remember, you have to multiply before you add. So don't say 5 plus 3 is 8 and distribute the 8. Mathematically, that's not correct. So you have to multiply first and then you would add the 5. So let's go ahead and distribute. So I get 4 times 3x is 12x. 4 times a negative 2 is a negative 8. A negative 7 times x is a negative 7x. And a negative 7 times positive 3 is a negative 21. Minus 3x equal, and then I get 5. And then distributed 3. Positive 3 times x is a positive 3x. And then positive 3 times a negative 2 is a negative 6. Alright, so I use the distributive property. Now I'm going to combine like terms. So I'm going to combine the variables first. So x to the first, so this term contains x to the first, and this term contains x to the first. So those are like terms. So I'm going to add those two terms together. 12x and a negative 7x and a negative, well, forget about the negative 3x. So 12 and a negative 7 is a positive 5. So I have 5x so far, and then 5x minus 3x is 2x. So I get 2x here. So those three terms are like terms. Then I have my constants. A negative 8 and a negative 21. When I combine those is a negative 29. Equal. Now on this side, the only two like terms are your constants, 5 and a negative 6. So I get 3x, and then 5 and a negative 6 is a negative 1. Now at this point, we're going to bring all the variables one side, constants to the other, and I'm going to go ahead and bring the variables to the right-hand side. So when I do that, I'm going to subtract 2x from both sides, and I get 2x minus 2x is 0, and 0 to negative 29 is a negative 29, equal 3x minus 2x is x, and then minus 1. And then all I need to do to get the variable x by itself is add 1 to both sides. And so when I combine like terms, a negative 29 plus 1 is a negative 28, equal, and then a negative 1 and a positive 1 is 0, and x and 0 is x. And there's your answer. You solve for x. So x is a negative 28. Now, I want to also mention this. So at this point, just to show you right here, so remember we had this equation. So I'm going to go ahead and rewrite it just to show you something. So remember, when I did the work, I said I was going to bring the variables to the right-hand side. So someone else, just to let you know, could have brought the variables to the left-hand side. So they would have subtracted 3x from both sides in this case. But you got to be careful though. 2x subtract 3x is a negative 1x. So that's negative x. Minus 29 equal, this is 0, 3x minus itself is 0, a negative 1. Then adding 29 to both sides, I get a negative x equal negative 1 plus 29 is 28. Now remember, you're trying to get x by itself. So we have to notice that the coefficient of x here is a negative 1. So if you need to, make sure you write it as a negative 1x if that helps you. And so then to get a positive 1x by itself, I'm going to go ahead and divide both sides by negative 1. Negative 1 divided by negative 1 is 1. 1 times x is x. and a positive 28 divided by negative 1 is a negative 28. So it did not matter whether you brought the variables to the right or the variables to the left. You still get, in both cases, the same solution. X is a negative 28. Okay? All right, now let's look at number 2. So number 2, we had a rational equation. It's still linear, though. It just so happens that we have fractions, but they're real numbers. There's no variable expression in the denominator. So this is still a linear equation. But the fact that we have fractions, the way that we're going to do this is we're going to go ahead and clear the fractions right at the beginning. So we got to find the least common denominator. So the smallest number that 3, 4, and 2 will go into is 12. So my least common denominator is 12. Then what I'm going to do is I'm going to multiply both sides by 12 to clear those fractions. Now the fact that I have two fractions on the left side and one on the right, I'm going to put the left side in parentheses or brackets. I'm going to do it like this. So 3x minus 4 divided by 3 minus 2x plus 5 divided by 4 in brackets, and then equal on the other side 4x minus 3 divided by 2. So all I did was I just rewrote the equation and I just put those in brackets because each side, the left and the right, have to be multiplied by the least common denominator. So I'm going to say times 12 times 12. So what you do to the left, you have to do to the right. So mathematically, everything you write has to be correct. Okay, so at this point, I'm going to go ahead and distribute the 12. Now remember, the whole point of multiplying by the LCD is to clear those denominators, meaning you want a factor of 1 in those denominators. So I get 12 times 3x minus 4 divided by 3, so 12 times that first rational expression, or that first fraction, minus, and then 12 times that second, 12 times 2x plus 5 divided by 4, equal, and I'm going to just go ahead and rewrite this one over, 4x minus 3 divided by 2 times 12. Alright, now at this point we're going to reduce. So remember, the whole point of multiplying both sides by 12 is to get 1 in that denominator, and now you can. 3 into 3 is 1, 3 into 12 is 4. Over here, 4 into 4 is 1, 4 into 12 is 3. Over here, 2 into 2 is 1, 2 into 12 is 6. Now, be careful. So this numerator right here is going to be, well, the expression, I should say, the expression that's in the numerator has to be multiplied by 4. So both of those terms. So you really should, to be careful, you need to put that in parentheses, all of these in parentheses. All right. Now, notice that these denominators are now 1s, right? So that's what you wanted. You wanted these to be factors of 1. So the next equation, the next equivalent equation you write will not have any fractions in it. So 3x minus 4 divided by 1 is still 3x minus 4. So this 3x minus 4 has to be multiplied by 4. So I'm going to write it as 4 times 3x minus 4. Same thing here, 2x plus 5 divided by 1 is 2x plus 5, but that's going to be multiplied by 3. So I'm going to say subtract 3 times 2x plus 5 equal, and then over here I'm going to get 6 times and put the coefficient of this expression in front. So 6 times 4x minus 3. So notice you don't have any variables, you don't have any fractions. So now it looks just like number 1, right? Just like this. So let's go ahead and distribute. So I'm going to distribute the 4, and over here, remember, subtracting 3 means the same thing as adding a negative 3. So I'm going to distribute a negative 3 here, and then distribute a 6. So I get 4 times 3x is 12x. 4 times a negative 4 is a negative 16. Negative 3 times 2x is a negative 6x. And negative 3 times 5 is a negative 30. Equal. And then 6 times 4x is 24x. And then 6 times a negative 3 is a negative 18. Combining like terms, just like in problem 1, I can combine the 12x and the negative 6x. So 12x and a negative 6x is 6x. A negative 16 and a negative 30 is a negative 46, equal, let's make sure oops, sorry, that's not negative 30, right? A negative 3 times 15 is negative 3 times 5 is a negative 15. All right, sorry about that. So a negative 16 and a negative 15 is a negative 31. So 6x minus 31, equal. All right, and then we have, I'm just going to go ahead and rewrite this over because there are no like terms on this side. So 24x minus 18. All right, now, just like the last problem, we're going to bring all the variables to one side, constants to the other. I'm going to go ahead and bring the variables to the right-hand side because the coefficient of x here is a positive 24. The coefficient of x here is a positive 6. And a positive 24 is greater than a positive 6. So when I bring them on this term on the other side, when I combine them, it will be a positive coefficient. So that's why I'm doing that. So I'm going to subtract 6x from both sides. Combine like terms. This is 0. Those are opposites. When you add opposites, you get 0. So I get 0 and a negative 31 is a negative 31 equal. Now 24x minus 6x is 18x minus 18. And then adding 18 to both sides, because right now I'm subtracting, so I have to add 18 to both sides. Once here, once there. A negative 31 and a positive 18 is a negative 13 equal. Combine like terms here, negative 18 and a positive 18 are opposites, so that means that when I add them up, I get 0. And I get 18x. And then finally, to get x by itself, all you do is divide both sides by 18, just like this. And then 18 divided by 18 is 1. 1 times x is x, equal negative 13 18ths. And that's the work. So, well, your solution, and that's the work you had to do. All right, so you had to show that work to get all of your points. All right, so that was number 2. All right, let's look at number 3. So number 3, we have, this time, we have a rational expression. This is not linear because if you notice your denominators are not real numbers. Your denominators are variable expressions. So this would be a linear equation if all of these denominators were a real number and your variables in the numerator were all raised to the first power. So the fact that we have variables in the denominator does not make it linear, it makes it rational. But you still have to find the least common denominator because I want to clear those fractions. First thing you have to do though is notice that this denominator right here is a quadratic expression. So I'm going to have to factor this. Now, usually what happens, not always the case, but usually what happens is that the factors of this quadratic expression will be the factors that you see here. So in other words, if you were to factor this, you would get x plus 4 times x plus 3. And you could check this by foiling this out, and you do. So x times x is x squared. The outer is 3x, the inner is 4x, and when you add them up, you get 7x. And then 4 times 3 is 12. All right. So your least common denominator, remember, has to include every factor that you see in the denominators. So I see an x plus 4 right here, so I have to have that in my least common denominator. Remember, your least common denominators are products, so don't put a comma here. That's a product. Your next factor you see is an x plus 3, right? So I'm going to put an x plus 3 as a factor. The next factor you see is an x plus 4. I already have it. The next factor you see is an x plus 3. I already have it. So your least common denominator is x plus 4 times x plus 3. That's the least. Always find the least. Now the restrictions, remember the restrictions are the values of the variables that makes the denominator 0, because that's where a fraction is undefined when the denominator is 0. So all you do is just look at each of those factors and you ask yourself, where is that factor equal to 0? So basically you're saying this. So if you look at x plus 4, so x plus 4 is equal to 0 when x equals negative 4, right? Because negative 4 plus 4 is 0. So 0 times whatever this is will be 0, and you cannot have 0 in the denominator. So that's a restriction, negative 4. Comma, we go to the next one, x plus 3. So where is x plus 3 equal to 0? Well, you solve this linear equation for x, and you get x to be negative 3. So there's the other restriction. Because when x is negative 3, this factor is 0. And 0 times this number right here will be 0, and we even get 0 here, don't we? Negative 3 plus 3 is 0, and 4 divided by 0 is undefined. Then notice that those factors here are the same as these, so the only two restrictions are -4 and -3. All right, now what we're going to do next is we're going to multiply both sides by the least common denominator. So you're going to say, now I'm going to go ahead and rewrite the left-hand side over and put that in a bracket because you have two rational expressions. So you're going to say in bracket 2x minus 1 divided by, now just as we mentioned in the lessons, don't write it as x squared plus 7x plus 12. Write it in factored form so that way you be able to see the factors. So x plus 4 times x plus 3 minus 3 divided by x plus 4 equal, and then 4 divided by x plus 3. So now we're going to multiply both sides by that least common denominator. So this is what you had to show. This first step had to be shown. All right, now the next thing you're going to do, just like you did in the previous problem, is you're going to distribute. So the LCD times that first rational expression. So x plus 4 times x plus 3 times 2x minus 1 divided by x plus 4 times x plus 3. Minus, and the same thing, the LCD times that second rational expression. X plus 4, x plus 3 times 3 divided by x plus 4 equal. All right, now I'm running out of room, so I'm going to have to write this a little bit smaller. So I get 4 divided by x plus 3 times the LCD, x plus 4 times x plus 3. Okay, now we're going to reduce. So the x plus 4's divide out, so notice you have factors of 1. Okay, the x plus 3's divide out, you have factors of 1's. Over here, the x plus 4's divide out, and then on this side the x plus 3's divide. So notice the factors of 1's in their place, and make sure you understand it does make sense because when you look at this right here, x plus 4 divided by x plus 3 times 2x minus 1 divided by x plus 4 times x plus 3, this part here is basically you're saying that divided by 1. So you have this rational expression times this rational expression, and then x plus 4 is being divided by x plus 4 in it. So x plus 4 divided by itself is 1. X plus 3 divided by itself is 1. Okay? All right. Now, the way you want to write the next step, you got to be careful. Okay? So you're going to say 1 times 1 is 1. All right? Now, 2x minus 1 divided by this product, 1 times 1 is 1. So 2x minus 1 divided by 1 is itself, 2x minus 1. So I get 1 times 2x minus 1. 1 times 1 is 1. Minus, now be careful here, you have 1 times x plus 3, x plus 3 times 3. So remember, multiplication is commutative. The order in which you multiply does not matter. So 3 times 1 is 3. So I'm going to write this as minus 3 times x plus 3 equal. And then over here, you get 4 times this 1 is 4, and so 4 is being multiplied by x plus 4. All right, so now we're at this point where you don't have any fractions left, so now we're going to distribute. Well, 1 times 2x minus 1 is 2x minus 1. Over here, I'm going to distribute the negative 3. So negative 3 times x is a negative 3x. A negative 3 times a positive 3 is a negative 9 equal. And then 4 times x is 4x, and then 4 times 4 is 16. Combining like terms on the left. Now notice there are no like terms on the right, but we do have them on the left. 2x minus 3x is a negative x. A negative 1 and a negative 9 is a negative 10 equal, and then 4x plus 16. Bringing the variables to one side, constants to the other, and I'm going to do it just like I did the last time. Notice that this coefficient is a negative 1, this coefficient of x is a positive 4. A positive 4 is greater than a negative 1, so I'm going to add x to both sides. And the reason why I'm doing that is to get the coefficient of x to be positive, and it tends to help a little if the coefficient is positive. But you could have brought the variables to the left. You would have had a negative x and a negative 4x though, and that would have been a negative 5x. So when you combine like terms, this is 0. 0 and a negative 10 is a negative 10 equal 4x plus x is 5x. So you see now your coefficient of x is positive 5. Whereas if you had brought it on the other side, it would have been a negative 5. And then plus 16. All right, so subtracting 16 from both sides, I have a negative 10 and a negative 16 is a negative 26 equal 16 subtract 16 is 0. 5x and 0 is 5x. And then finally, to get x by itself, we're going to divide both sides by 5. 5 divided by 5 is 1. 1 times x is x. And this is, you can't reduce any further, so you just say negative 26 fifths. Now, if you wanted to, now notice this is improper, right? That's an improper fraction. So if you wanted to, you could have written it as a mixed number. So 5 into 26. So 5 goes into 26 5 times. 5 times 5 is 25. Subtract, you get a remainder of 1. So you could have written it as negative 5 and 1/5. Negative 5 and 1/5. Okay? But most students will leave it as an improper fraction. Just make sure it's reduced, and it is. And that's it. So that is the work you had to show. All right, so that was number 3. Okay, now let's look at number 4. So number 4, now remember, always read the directions. So number 4, you were asked to solve, sorry, right here. Number 4, you were asked to solve this quadratic equation by factoring. All right, so make sure you follow the directions. Don't use the quadratic formula when it tells you, when the directions tell you that you must use factoring. All right, so I have this quadratic equation here. It's in standard form. I have 0 on the other side. And the GCF of those three terms is 1. So since the GCF is 1, I'm just going to go ahead and then factor it as a product of two binomials. Just make sure you say equals 0 because each thing you write has to be equivalent. So everything you write mathematically has to be correct. Okay, so this is not that bad because the coefficient of x squared is 7, which is prime. So the only two products, the only two factors of 7 is 7 and 1. So I'm going to say 7x and then 1x. Now for 6, there are two possibilities. You could say 6 and 1, 3 and 2. I'm going to use 3 and 2. And the one that's going to work will be where the 3 is in this second parentheses, or the second factor, or this factor, and then the 2 is in this factor. Now remember, the last sign's negative, so in order to get a negative 6, that means that these signs here have to be different. And then I want the middle term to be a positive 19. So that means that if I look at this, the outer and the inner, the outer is 21, and the inner is 2. So that means that 21 has to be positive because that's the larger one. So that means that this is plus, so this is x plus 3, and then that means that this is 7x minus 2. And you can always fall it out and verify you get this. Now once you write it in this form, where you have, in this case, two factors whose product is 0, then you're going to use a 0 factor property. So that means that 7x minus 2 has to equal 0. So one of those factors has to be 0 because that's the only way you can get a product of 0. And the other one is that x plus 3 is equal to 0. And then you just solve each of those linear equations. So I get 7x equal 2. So x is 2 sevenths. Over here, x equal negative 3. And those are your two solutions. So 2 sevenths and negative 3. All right. Now number 5, you want to solve this quadratic equation. Now it is not factorable. So you could use the so there are only two other methods that you know of that we studied. You could use the quadratic formula, or you could use completing the square. Most students will use the quadratic formula, so that's the one we're going to use. And I do tell you, by the way, to use the quadratic formula. All right, now when solving a quadratic equation using the quadratic formula, you're going to put it in standard form just like we did in number 4, meaning that you want all the terms to one side and 0 on the other, and we're going to put it in descending order. So basically all I need to do here is bring this constant to the left hand side. So I'm going to get 4x squared minus 3x minus 3 equals 0. And the next thing you do is, and most students do this, is they'll label the a, b, and c that I need to put into this quadratic formula. So remember, a, though, is a coefficient of x squared. So the coefficient of x squared is 4. b is the coefficient of x, which is a negative 3, not a positive 3. And then c is your constant, which is a negative 3. So be careful. Some students will say 3 because they see a 3 here, but you have to put it in standard form. You need 0 on that other side. All right. And then we're going to take those values of a, b, and c and substitute it back into the formula. So remember, you're solving for the variable x. You're going to say x equal. Now remember, this part right here, negative b, means the same thing as the opposite of b. So if b is a negative 3, the opposite of a negative 3 is a positive 3. Plus or minus the square root of b squared. So I'm going to take b, and we'll put that in parentheses. B is negative, and I'm squaring that. Minus 4 times a. A is 4. And then times c, which is a negative 3. All of that. Now remember, you had to extend this. Make sure you write things mathematically correct. So you're going to go from here and then draw the division symbol all the way to the end. And divided by 2 times a, and a is 4. All right, now we're going to go ahead and simplify the discriminant. So remember, when you're talking about the quadratic formula, the b squared minus 4ac has a special name, and it's called the discriminant. But in general, a radical expression, that the part that's under the radical symbol, is called the radicand. So we're going to go ahead and simplify the radicand. And remember, whenever you're looking at b squared should never, b squared is never negative. So if you said on your calculator negative 3 squared and you got a negative 9, that's incorrect. B squared is never ever negative. So when we square negative 3, we get a positive 9, not a negative 9. So I get 3 plus and minus the square root of 9. And then a negative 4 times a positive 4 is a negative 16. And a negative 16 times a negative 3 is a positive 48. So I get 9 plus 48. All of that is being divided by 2 times 4, which is 8. And then we're going to go ahead and add 9 and 48 together. And when I do that, I get 3 plus and minus the square root of 57 divided by 8. Now, 57, there is no perfect square other than 1 that goes into 57. So we're done. You cannot simplify the square root of 57. So there's your answer. So it'll be 3 plus and minus the square root of 57 divided by 8. Now, if you wanted to write those two solutions, then there are two solutions, right? 3 plus square root of 57 divided by 8, and then 3 minus square root of 57 divided by 8. But if you wanted to write those separately, you could, just like this. And then 3 minus square root of 57 divided by 8. All right, so that was number 5. So now let's look at number 6. So this is number 6. So number 6, I want to solve this quadratic equation, but I'm asking you to solve this using the square root property. Now, you have to recognize that the square root property is so easy to use whenever you have an expression that's being squared. And on the other side, you have a real number, like negative 32 is a real number. And so whenever you have that situation where you have some expression squared equal a real number, then all you have to do is, to solve for the variable x, is take the square root of both sides. But remember, when you take the square root of both sides, you're going to have plus or minus on one of the sides. And so the square root and the squaring function undo each other. So you're left with 4x minus 5 equal, and then you get plus or minus the square root of a negative 32. Now, you learned about imaginary numbers, so don't say all of a sudden that this is not a real number. You're right, it is not a real number, but you know how to go further. And so if you don't go further, you don't get all your points. So you have to recognize that the square root of a negative 1, we defined that to be the imaginary unit I. So the square root of a negative 1 is not a real number. It's an imaginary number, which we define to be represented as I. And so then the square root of 32 is, I can simplify that because the largest perfect square that goes into 32 is 16. So I can write this as square root of 16 times the square root of 2. And the square root of 16 is 4. So this becomes 4 square root of 2. So what that means then is that the square root of a negative 32 is the same thing as saying square root of a negative 1 times the square root of 32. And we know that the square root of a negative 1 is I. And we know that the square root of 32 now is 4 square root of 2. And I'm going to go ahead and rewrite this product by putting I between 4 and square root of 2. So we can say 4I square root of 2. Okay? So that goes here. So it becomes 4x minus 5 equals plus or minus 4I square root of 2. And then all you do is to get x by itself is you're going to add 5 to both sides, and then you can divide by 4. So let's go ahead and add 5 to both sides, just like this. And combine like terms. The only terms I can combine on the left is the 5 and negative 5. When I combine those, I get 0. And so I get 4x equal. Now, notice that this term right here, 4I square root of 2 and 5 are not like terms. So the only way you can write this is to say 5 plus or minus 4I square root of 2. 5 plus or minus 4I, that's an I, square root of 2. And then all you do is divide by 4, and you're done. Just like this. So you get x equal 5 plus or minus 4I square root of 2. All of that is being divided by 4. All right, so that was number 6. All right, number 7, you want to solve this polynomial equation by factoring. In particular, this polynomial equation, if you look at the larger exponent, which is 3, is a cubic equation. Now, in previous lessons and also in previous courses, you had some experience, for some of you it may have been a while, but you've had experience on factoring. So when you have 4 terms, normally, it's not always true, but normally what you want to try is to factor by grouping. And what sometimes works is to try grouping the first 2 terms and then group the last 2 terms. And so if you look at the first 2 terms, just the first 2 terms, you'll notice that the greatest common factor of the first 2 terms is x squared. So that means I could factor out an x squared. And when I factor out an x squared, I get x squared times x is x cubed minus, and then x squared times 3, that's a 3, will be a negative 3x squared. Now, for the second group, you have to recognize that this the GCF of the second group is 11. But remember, you're always going to factor out that sign right here. So you're going to say plus 11 times, and then 11 times x is 11x, and then 11 times a negative 3 is a negative 33. And then you need to recognize that these 2 expressions here, these 2 products that you see here, they both have x minus 3 in common, which is what you needed. Now I'm going to factor out that x minus 3. So I needed to see that other step, because remember I did say solve by factoring. So I need to see a product of factors. This is not a product of factors because of that addition symbol. So you're going to write as x minus 3 times, and then when you factor out the x minus 3, you're left with x squared and 11. So you can say x squared plus 11 equals 0. And then now you got to recognize, hey, I have a product of factors is 0, and so you're going to set each factor equal to 0. So you're going to say x minus 3 equals 0, x squared plus 11 equals 0. And so I went from a cubic equation to a linear and a quadratic. And the linear is easy, so you get x to be 3. Now in this quadratic, you need to notice that the x term is missing. You have an x squared and a constant. So since the x term is missing, I'm going to use the square root property. And basically all I need to do is just say x squared equals a negative 11. And once you write x squared equal negative 11, you know that you can get x by itself by getting rid of the squaring part. And to do that, you're going to take the opposite. The opposite of squaring is to take the square root. Don't forget the plus or minus. So the square and the square root don't do each other, so you get x equal plus or minus. And then you got to remember, square root of a negative 11 means the same thing as the square root of a negative 1 times the square root of 11. Square root of negative 1 is I. 11 is a prime number. So the only perfect square that goes in 11 is 1. So that means that I cannot simplify the square root of 11. Alright, so I get plus or minus I square root of 11. And so you have 1 and then these other two solutions, so you have 3 solutions all together. So you get 3, and then you can say plus or minus I square root of 11. Or if you want to, you can write as three separate solutions. 3, positive I square root of 11, negative I square root of 11. Alright, so that was number 7. Okay, so let's look at number 8. So number 8, you had this right here. So you wanted to solve this quadratic equation, but you wanted to do this using U substitution. So you need to recognize that to use substitution here, that 2x minus 1, the expression 2x minus 1 is located here and here. So that means that if you let u be the expression 2x minus 1 right here, and you go back and in place of 2x minus 1 you substitute u, you'll recognize, hey, this is a quadratic equation. You get 3 u squared, so in place of 2x minus 1 I put u, plus 8u minus 3 equals 0. And so you have this quadratic equation, and now you're going to solve for the variable u. Now this is quadratic. For some people, they don't recognize it's quadratic, but it is, because if you did square, see right here it's saying square 2x minus 1, you would, if you cover up the 3, when you did square this, you would end up with a 4x squared. And then 4x squared times 3 would be a 12x squared. And so this would be quadratic. So now we got to factor, or use the quadratic formula, does not matter. The one that you have will be factorable when you get to this point. But if it's not factorable, then go ahead and use the quadratic formula. But it is. So we're going to go ahead and factor this. And so when I factor this, I'm going to get 3u in u. And the only possibilities for 3 would be 3 and 1 over here. So to get a positive 8u as a middle term, I need this to be 3 and this term to be 1. The last sign is negative, so these signs have to be different. And since I want the middle term to be 8u, a positive 8, then this is 9u, this is 1u, so that means that 9u has to be positive. So we get this. And now we're going to set each factor equal to 0, just like this. And then we're going to solve for u. So when I solve for u, I get 3u equal 1, so u is 1/3. Over here, I get u equals negative 3. Now remember, my equation had the variable x, not u. So now I've got to go back and solve for x. So that's where you resubstitute. So I take both of these now, and wherever we see the variable u, I'm going to substitute back 2x minus 1. So I get 2x minus 1 equals 1/3. 2x minus 1 equals a negative 3. So 2x minus 1 equals 1/3. 2x minus 1 equals a negative 3. So to get x by itself, I'm going to go ahead and add 1 to both sides. So I get 2x equals 1/3 plus 1. So now you got to figure out what 1/3 plus 1 is, right? So basically you're saying 1/3 plus 1. Now remember, I can write 1 as 1 divided by 1. So now you're going to find the least common denominator to add those two fractions. So the least common denominator is 3. And then you're going to write equivalent fractions. Well, 1/3 is equivalent to itself. So 1/3 is the same as 1/3. But I want to write the number 1 as an equivalent fraction with the denominator 3. So right now my denominator is 1, but if I multiply by 3, I get 1 times 3 is 3. But what I do to the denominator, I do to the numerator. So 1 times 3 is 3. Makes sense, right? Because 3 divided by 3 is 1. And now I can add those fractions. 1/3 plus 3/3 is 4/3. All right, so now this side is now 4/3. So I get 2x equals 4/3. Okay, so now I got to divide both sides by 2, right? So I'm going to go ahead and rewrite this over. So I'm going to divide both sides by 2 to get x by itself. 2 divided by 2 is 1. 1 times x is x. Now you have to recognize that you have a fraction being divided by another fraction, 2 divided by 1. So when you have that, you remember you got to change this to a multiplication problem. So we're going to take the numerator, which is 4/3, multiplied by the reciprocal of the denominator. The reciprocal of 2 is 1/2. And then notice I can reduce. 2 divided by 2 is 1. 4 divided by 2 is 2. And now we can multiply. 2 times 1 is 2. 3 times 1 is 3. And so there's one of your solutions, 2/3. On the other one, I'm going to add 1 to both sides. I get 2x equals a -3 plus 1 is a -2. Divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. -2 divided by 2 is a -1. So there's your other solution. All right. So that was number 8. So number 8, you had to use substitution. That was what you were asked to do. Okay. Now let's look at number 9. All right. So number 9. I'm going to pull this over. So here's number 9. All right, so number 9, we have this compound inequality. Now, this compound inequality, I want you to notice that the variable expression is in the middle. So you have if I cover this part up, you have 2x minus 5 is less than or equal to 8, and at the same time, 2x minus 5 has to be greater than a -6. So for this compound inequality, it's easier to solve this compound inequality. It's more efficient if you get x in the middle. So it's kind of like saying, if you cover this part up, what would you do to solve this inequality? Well, you'd add 5 to both sides, right? So you'd add 5 to both sides. Well, but there are 3 parts, so you really have to add 5 to all 3 parts. And so -6 and 5 is a -1 is less than -5 and 5 is 0. So you get 2x is less than or equal to, and then 8 plus 5 is 13. And then if you just had this, then how would you get x by itself? Well, to get x by itself, you would divide both sides by 2. But remember, there are 3 parts, so you have to do all parts. And so now you have -1/2 is less than 2 divided by 2 is 1. 1 times x is x is less than or equal to, and then 13/2. And you could leave it as an improper fraction. This is proper, but this is improper. You could leave it as an improper fraction or write as a mixed number. I'm just going to leave it as 13/2. Now, when writing your solution interval notation, you got to recognize if this number here, -1/2, is a solution or not, and then if 13/2 is a solution or not. And to determine that, you look at that equal sign. So x can equal 13/2. X here cannot equal -1/2. So in terms of interval solution, you're going to put -1/2 in parentheses like this, so parentheses -1/2, comma, all the way to 13/2 with a bracket. So any real number that's in this interval, so if you looked at this in terms of a graph, here's 0, let's say this is -1/2, and let's say way out here is 13/2, right? So that means that if I shade in the solutions, notice this is parentheses, this is bracket. If I shade in the solutions, I have an infinite number of solutions. So all these numbers, all these real numbers, that's from -1/2 to 13/2, not including -1/2, but including 13/2 is a solution. All right. Now this is the graph. I didn't ask you to graph it, but that is the graph, and then that's the interval notation. So that was number 9. Okay, now let's look at number 10. Okay, so number 10, you had this radical equation, this square root equation. And this is not that difficult because, first of all, the radical expression is by itself. So whenever the radical expression is by itself, then you want to get rid of square root. Remember, the opposite of squaring, square rooting rather, is to raise both sides to the second power. And so let me go ahead and rewrite this over. So I have the square root of 14 minus 7x equal, and then x minus 2. So to get rid of that square root, the first thing you're going to do is square both sides, just like this. Notice parentheses on this side, parentheses on this side. And so now when I square this square root of 14 minus 7x, the square and the square root function undo each other. And so you get 14 minus 7x equal, now you're going to have to square x minus 2. But remember, when squaring x minus 2, you're squaring a binomial. So if you wanted to, you could write it like this and then FOIL. So I get x times x is x squared. The outer is a negative 2x. The inner is a negative 2x. And the last, a negative 2 times negative 2 is a positive 4. Combining the like terms, I get x squared. A negative 2x and a negative 2x is a negative 4x, and then plus 4. All right, so x squared minus, x minus 2 squared is this quadratic expression. So that becomes x squared minus 4x plus 4. Okay? All right, now you have to notice that I went from a square root equation to a quadratic equation. This is quadratic. So since it's quadratic, I'm going to go ahead and put in standard form. So first of all, I'm going to go ahead and transpose the sides because I want the when I write this in standard form, I want the expression to be on the left side and 0 on the right. So I'm going to just go ahead and transpose the sides real quick, just like this. So if the left side equals the right side, then the right side is going to equal the left side, right? All right. And then I'm going to bring the two terms to the left, so I get x squared minus 4x plus 4. When I bring the 14 over, I get negative 14. When I bring the negative 7x over, I get positive 7x equals 0. Then combining like terms, I get x squared, a negative 4x, and a positive 7x is 3x, positive 3x. 4, a positive 4, and a negative 14 is a negative 10. And so now I have this quadratic equation. And you can use the quadratic formula to solve for x, or you could factor. Remember, the ones we have will be factorable. So when you factor this, you get x plus 5 times x minus 2 equals 0. And you can check it. When you follow this out, you will get x squared plus 3x minus 10. And then I have two factors whose product is 0, so by the 0 factor property, I'm going to set, one of those has to be 0, so I'm going to set each one equal to 0. And so notice I went from a radical equation to a quadratic equation to two linear equations. And so I get x to be negative 5 and x to be 2. Now, one of the things you have to remember is that when you raise both sides to an even power, you could introduce extraneous solutions. So there's false solutions, meaning that these two proposed solutions here, these two solutions that you see here, those are solutions to this quadratic, but they may not be solutions to the original. All right, so you have to check, and I gave you a hint. I said, I told you, I said, make sure you show the work for when you check for the extraneous solutions. So I gave you the hint. The hint was, make sure you show the work for extraneous solutions. You have to check, and you have to show that you're checking. So show the work for checking here. Okay, so let's check x equal negative 5. So I'm going to go ahead and rewrite the original equation over, the square root of 14 minus 7x equal x minus 2. Wherever we see the variable x, I see x on both sides, I'm going to substitute negative 5. So you get the square root of 14 minus 7 times negative 5. And I want to see if that's going to equal negative 5 minus 2. So this radicand right here becomes the square root of 14. A negative 7 times a negative 5 is a positive 35. And on the other side, a negative 5 and a negative 2 is a negative 7. Going back over here, 14 plus 35 is 49. So I get the square root of 49. And the square root of 49 is 7. Now comparing those two, 7 does not equal negative 7. So that means that x equal negative 5, that means that this is an extraneous solution. So it is a solution to this quadratic equation that you see here, but it's not a solution to the square root equation. And so that's extraneous. Now we do the same thing for x equal 2. I'm going to go ahead and rewrite the equation over. You have the square root of 14 minus 7x equal x minus 2. So wherever we see the variable x, I'm going to substitute 2. So I got the square root of 14 minus 7 times 2 equal, and I want to see that's going to equal, remember x is 2, so 2 minus 2. But right away we see that 2 minus 2 is 0. All right, now let's check on this side. So I have the square root of 14. A negative 7 times 2 is a negative 14, right? 14 minus 14 is 0, and the square root of 0 is 0. And those two sides are equal. So x equal 2 is the only solution. That's your only solution. So now you are asked to determine, are there any extraneous solutions? And the answer is yes, we found an extraneous solution. If so, what is the extraneous solution? The extraneous solution is x equal negative 5. And then what is the real solution to the original equation? And the only real solution is 2. And that's what you have to write. All right, so that's number 10. Now let's look at number 11. Now number 11, you have another rational equation. And just like in the previous rational equation, number 3 I think it was, you're going to find the least common denominator. So just like previously, you're going to factor your denominators. Now x plus 3 and x minus 2 cannot be factored any further, but this quadratic expression here can. And so when you factor this, you're going to get x plus 3 times x minus 2. Now notice the directions said find the LCD and indicate the restrictions. Now I don't have it written out here, but you still had to do that. So the least common denominator is the product of each of the factors you see, just like we talked about in number 3. So my least common denominator will be x plus 3. I see a factor x minus 2, so that's going to be there. I see x plus 3, but I already have it listed. I see x minus 2, I already have it listed. Don't list it again, because then it's no longer a least. It's a common denominator, but not the least. Always find the least. It makes things easier for yourself. Then to find the restrictions, so what can't x be? So remember, we can never divide by 0. So if you look at x plus 3 and ask yourself, when is this expression 0? You're going to see that x plus 3 is equal to 0 when x equals a negative 3. Over here, x minus 2 is equal to 0 and x equals a positive 2. Your next factor you see is x plus 3, but I already took care of that. That's going to be negative 3 will make that 0, and then positive 2 will make that 0. So there's only 2 restrictions. Now the next thing you're going to do is you're going to multiply both sides by the least common denominator. That's what I wanted you to do. And the idea is to clear those fractions. Now the left-hand side has 2 rational expressions. I'm going to put that in parentheses. So x divided by x plus 3 minus 3 divided by x minus 2. So I put those in brackets. On the other side, I just have one rational expression. So I get x minus 17 divided by, and remember, always write the factored part. So x plus 3 times x minus 2. And at that point, you're going to multiply both sides by the least common denominator. So x plus 3, x minus 2. On this side, x plus 3, x minus 2. And then now you distribute, just like we did with number 3. So you have your LCD times that first rational expression. So the LCD times that first rational expression, x divided by x plus 3, minus the LCD, x plus 3, x minus 2, times that second rational expression, equal, and then the right side times the LCD. So x minus 17 divided by x plus 3, x minus 2, times x plus 3, x minus 2. Okay? Now we're going to reduce. So the x plus 3's divide out. Make sure you put factors of 1 in there, in that place. Over here, the x minus 2's divide out. And over here, the x plus 3's divide out and the x minus 2's divide out. And so notice, remember the whole idea of multiplying by the LCD is to get these factors in the denominators to be ones. So that way you don't have any fractions to deal with. All right, now I have, remember, multiplication is commutative. You have 1 times x minus 2 times x. So the order in which you multiply them does not matter. So I need to recognize why I'm doing it the way I'm doing. So I have 1 times this monomial x, the monomial factor here, x, is x. I'm going to put x in front. So I get x times x minus 2. Over here, subtract, don't forget you're subtracting, you have x plus 3 times 1 times 3. So 1 times 3 is 3, so I'm going to put the 3 in front. So I get minus 3 times x plus 3 equal. And then here you have x minus 17 times 1, which is just x minus 17. Now I'm going to go ahead and distribute in both cases here. X times x is x squared. X times a negative 2 is a negative 2x. Negative 3 times x is a negative 3x. Negative 3 times a positive 9 is a negative 9. Equal, and then x minus 17. I want you to notice that I went from a rational equation to a quadratic equation. So this is quadratic. Let's go ahead and combine like terms. I have x squared. Negative 2x and a negative 3x is a negative 5x minus 9 equal x minus 17. So now what we're going to do is I want to write this quadratic equation in standard form. So I need 0 on one of the sides. So since x squared is positive on this side, well, has a coefficient of positive 1 on this side, I'm going to go ahead and bring the two terms here to the left. So I get x squared minus 5x minus 9 minus x plus 17 equals 0. And then combine the like terms again. I have x squared. A negative 5x and a negative x is a negative 6x. A negative 19 and a positive, negative 9 and a positive 17 is a positive 8. And that's equals 0. And so now I can factor this or use the quadratic formula, whatever one you want to use. And when I factor this, I get x times x is x squared. There are two possibilities for 8. 8 times 1, 4 times 2. I'm going to use 4 and 2. I'm going to put the 4 here, the 2 there. Notice the last sign's positive. That means these signs have to be the same, and it has to be that middle sign. So both are negative. And always verify. Multiply this out to see if you get x squared minus 6x plus 8 back. And now I have a product, two factors whose product is 0. So the 0 factor property says one of them has to be 0. That's the only way you can get a product of 0. So I'm going to set each of those equal to 0. And so I get x equal 4 and x equal 2. Now those are your proposed solutions. So my proposed solutions are 4 and 2. Those are the solutions to this quadratic equation. That's what that is. These two solutions are the solutions to this quadratic equation. But my original equation was not quadratic. My original equation was a rational equation, and remember you had restrictions. So I want you to notice that your restrictions are negative 3 and 2. One of my proposed solution right here is a restriction, right? That's a restriction. So it means that I cannot use x equal 2. So 2 is a solution to this quadratic, but it's not a solution to the original. So that's a false solution, so that's an extraneous solution. So your extraneous solution is 2. So are there any extraneous solutions? Yes. If so, what is it? 2. So that means that the only solution is 4. 4 is the only solution. All right, so that is the key to those problems that were on your test. All right, so make sure you go back over the problems, look at how you did on the test, compare your work with the key and the explanations, and just prepare for the next test. All right, well, that's it.